All right, so like I said, we're going to do one last quick set of notes on the law of conservation of mass. And as we said before, that the law of conservation of mass just says that matter cannot be created or destroyed. It simply changes form. So if we look at this picture here, I have vinegar, as soon as my pen decides that it wants to write. Vinegar, and it tells me that the chemical equation for that is C2H4O2. I have baking soda, which is NaHCO3. And we know that if we've ever mixed these before, baking soda and vinegar make this bubbly reaction over here. And so what it actually makes, it's called sodium acetate plus water plus carbon dioxide gas. And we also talked before about how over here these are my reactants and these are my products. So when I'm talking specifically about the law of conservation of mass with chemical reactions, it means that whatever I have to start with has to be the same as what I end up with. So if I look at my, let's count up my atoms here. So I have hydrogen. I have 4 atoms here and 1 here. So I have 5 hydrogen atoms. I have oxygen. I have 2 here and 3 here. So that is 5 oxygen atoms. I have 2 carbon and 1 carbon, so I have 3 carbon atoms, and I have 1 sodium atom on my reactants side. Over here, I have 3 hydrogen plus 2 hydrogen, so I have 5 hydrogen atoms. I have 2 oxygen plus 1 is 3 plus 2 more is 5 oxygens. Oops. I have 1 sodium atom. And I have 2 carbons here and 1 here, so I have 3 carbon atoms. So if I compare my sides, I have the same numbers of each of these atoms of my reactants as I do of my products. I did not create or destroy any of my matter, it just changed from one form to another. If I was able to take the mass of all of this information in a lab, I would also be able to tell, let's say we just put some numbers on here. If I had 5 grams of vinegar plus 5 grams of baking soda, if I combined them all and was able to trap my carbon dioxide, I would still end up with 10 grams of the products. Hey guys, Tommy, I'm recording a video, Bug. All right, so this is telling me that this is showing me that bonds were broken. I broke the bonds between these carbons and these hydrogens and oxygens and the sodiums, hydrogens, carbons, and oxygen. They were rearranged. And that everything is still there. So another example down here is that matter doesn't turn into or appear from energy. Nothing is lost, and particles don't just appear or get created, their arrangements are changed. So if I am burning a fire, the mass of the wood plus the oxygen, which would be a little bit difficult to measure in real life, but the mass of the wood plus the oxygen would be the same if I was able to measure it of the mass of the ashes, the carbon dioxide gas, and the water that was left. And if I did a chemical equation of this, I would end up with the same amount of hydrogen and oxygen and carbon atoms on both sides. So all that the law of conservation of mass says in fancy words is the number of atoms is the same on both sides. Whoops. Stays the same on both sides. and the mass stays the same on both sides. And the fact that the number of atoms stays the same on both sides is how we're going to start talking about balancing equations in the future.